So with the 1.5 rank and homogeneous system, and then last time I made an error too. The spell was not right. Okay, so we had the homogeneous system last time, right? In beginning sections. Homogeneous system, other constant is the 0. There is a homogeneous system, right? So homogeneous system of equation, we have all the vector variables. Now we have a coefficient, and other side we get the 0. That is a homogeneous equations, right? Okay, now if all the solutions, because we are learning the solution, right? So all solutions are 0, then we called this is a trivial solution, because all solutions are 0, right? It's a trivial solution. Yeah, homogeneous, correct, yes. The superior is not, okay, let me see. Yeah, okay. Homogeneous, yeah. Homogeneous. Correct? Oh, then why so complicated? Yeah. There we go. I have it here. So homogeneous. Oh my goodness. All right. Okay, homogeneous system, right? Okay. So now we express this one as a homogeneous system of equation. Now all the solutions are 0, then we say the trivial solution, right? Okay, then what if it's not all, just some, right? Sum is equal to 0, and sum is equal to some numbers, then we say the non-trivial solution. Terminology, right? So we should know that. Non-trivial. Okay, I changed the color. It does not work. Okay, now let's talk about this one. Look, we have M equation here. This is M, yeah? So M equation. First equation, second equation, third until M, right? Okay, there is M equation using N variables, right? So basically M is the row and N is column. So first column, second column, third column, N column, right? So M by N. We have M by N, right? So this is a row, this is a column, and we can say that this is the equations, right? Equations for the row and column for variables, right? Yeah. So if we say that M is less than N, that means there's more variables than equation, right? More variables than the equation. Then there is always has a non-trivial solution Okay, so here's a non-trivial solution. And also, it's not only trivial solution, also this is infinitely many solutions, all right? Infinitely. Infinitely many solutions. Okay, let's talk about that. So we have example, find the non-trivial solutions. So let me just cut the following homogeneous system of equation. So x plus y minus z equal to 0 and x plus 2y minus 2z equal to 0, right? Okay, so we just say that there is two equations, more variables. So basically 2 by 3, right? Then there is more variables, so there is infinitely many solutions, right? So we can use that. This one, right? Copy. There. So note.
I have a question. So the zeros don't count as columns?
Yeah. Uh-huh.
Okay. So it's
Yeah.
just the X, Y, and Z that are columns.
Mm-hmm. Yes. Yeah. Because they talk about the variable, right? Okay, now let us do. So we're gonna make augmented matrix here. Two, one, 1, 2, -1, -2, 0, 0. Okay. We are using elementary row operation. So we switch over because 1 is here, right? So we're using this notation, right? So row 1 exchange with row 2. So we get 1, 2, -2, 0, 2, 1, -1, 0. Okay, now we want to make a 0 here. How? It's equivalent matrix.
Should we multiply row 1 by -2?
Good job. So we do -2 R1 plus R2 to get R2. So we get 0, -3, 3, 0, correct? Okay, we want to make a 0 here. Or shall we make a, okay, sure. Let us make a 1 first, more easier, right? So hold on 1 second. We want to make a 1 here. How?
Multiply row 2 by -1/3.
Excellent. So R2. So we have 0, 1, -1, right? Okay, now we want to make a 0. So -2 R2 plus R1 to get R1, right? So that will be 1, 0, 0, 0, 1, -1. Okay. So we have this is a pivot, right? So basically X, Y, Z there. Let me write down first. This is a pivot. This is a pivot. There is no pivot. So we said that this is a free variable, right? Z is a free variable. Yes? So we have X equal to 0. Let me write down first row. So X equal to 0. Second row, Y minus Z equal to 0. Then since the X is the pivot column, Y is the pivot column, Z is not pivot, so Z is free variable, right? Then we can set it up as a parameter. So say T. So it means that we can put any number, right? So then Y minus 2, so that is Y equal to Z, which is Y equal to T as well, right? So look, we can see that this is the infinitely many solutions, right? Because we can set up T any number, 0, 1, 2, 3, 400 million, 123, any number, then Y equal to and X equal to 0, right? So now this one we can express as this way. So we have constant 0 there, right? We can express this one. X equal to 0, Y equal to 0 plus T, parameter T, Z equal to constant equal to 0, and parameter equal to T, all right? Okay, this one we can express as a column matrix. So that will be X, Y, Z. And then first term, which is 0, 0, 0. Second term, they don't have a T, so 0, T, T, right? Okay, this one, we want to factor out the T. So this will be 0, 0, 0 plus T. But first one don't have a T, so 0. And second one is 1. And third one is 1. Okay, this is how we express. All right, now we have another vocabulary here. Basic solution. So basic solutions. So we have a basic variable last time. Basic variable was not free variable, right? So basically we have this column is a free variable, which is Z. Where it go? Yeah. This one is a free variable because there is no pivot. Then we say that this is a basic variable, right? So let me write down. This is from the last time. This is a basic variable. So basically X is a basic variable and Y is basic variable, right? And G is free variable, right? because there's no cubic. And this is cubic, has a cubic. So basic value vocabulary, right? Now, basic solutions. So they say the basic solution of a system are columns constructed from coefficient. So basic solutions of system are columns constructed from the coefficients on parameters in the solution. Okay, so they're using column matrix. This notation, the uppercase X, and just index only once. So they're using that. And they talk about the coefficient, right? Coefficient on parameter. Coefficient on parameters. So we are reading coefficient here. So there will be 0, 1, 1. That is the basic solution, okay? So this notation is the column matrix. Okay, let us do this one. So we have x plus 4y plus 3z equal to 0, 3x plus 12y plus 9z equal to 0. Find the basic solutions to this system. Once again, they have two rows, two equations, and more variables, more columns, right? So there is infinitely many solutions. If there is infinitely many solutions, then there is a parameter, right? Then there is a basic solution, same as earlier, right? Okay, let us do this. So we're writing augmented matrix, which is 1, 3, 4, 12, 3, 9, 0, 0. So equivalent. Okay, we want to make a 0 here. How?
Multiply by -1/3 and add row 1.
Okay, so -3 R1 plus R2 to get R2. Okay, so we have a 0, 0, 0, 0. What do you think? Yes? Okay, let me write down first row, which is x plus 4y plus 3z. Okay, look. There is cubic. Cubic column, right? Cubic column. So we call this is a basic variable. and free variable in Z, Y free variable as well. Okay, so let us do this. X equal to -4y minus 3z, right? Okay. Since y and z has a free variable, let's say the s, and z equal to t, okay, so there will be, we have s term, let me write in here, so x will be -4, y equal to s, minus 3z equal to t. So we can make two terms, s term and t term, right? So let us do that. So x, y, z. So one is s term, is a -4s, s, 0. And we have a t term, which is -3t, 0t, right? Now parameter, we can factor out. So we will get s, the -4, 1, 0, and plus t factor out, so -3, 0, 1. Okay, so we have a basic solution. We are using this notation, which is one is, they say that coefficient on parameter, so only coefficient, so -4, 1, 0, and another one, which is coefficient on parameter, which is -3, 0, 1. Okay. All right. So let us do this one. Linear combination. Some of you heard this one, this terminology before, right? Linear combination. So we have let uppercase X means that column matrix, right? Oh, they already said it here. X sub 1, X sub 2, X sub n be column matrices. So if we have one matrix, then matrix, right? If more than one, we call the matrices, right? Okay, now then V is said to be a linear combination, linear combination of the columns matrix, right? So V X sub 1, X sub 2, X sub n, if there exists scalar is just a number. real number, right? So scalars, a sub 1, a sub 2, a sub n, such that, so we're gonna have this form. Look, we have V equal to a sub 1, x sub 1 plus a sub 2, x sub 2 plus a sub n, x sub n. So linear combination. So V is linear combination of the columns matrix. Then the form is like that, right? So we said that V is a linear combination of a column matrix. So we have a scalar and then multiple of addition, right? Okay, so this one looks like a linear combination. Let me write down for you. Example of linear combination. Okay, so the scalar, which is a 3, and the column matrix, which is -4, 1, 0, and +2, -3, 0, 1. We have not learned anything yet, right? So let me write down. This is a sub 1, this is x sub 1, and this is a sub 2, x sub 2, right? And we're gonna get the V. This one just like a distribute, so we will get -20, 3, 0, and plus -6 plus 0. How about this way better? Yeah. -6, 0, 2. Okay, what do you get? -18, 3, 2, right? So we say that this is a V. This is the answer V, right? So we say that this is V is a linear combination of the column matrix of x1, x sub 1, x sub 2, right? Okay. Now, we have another terminology. Rank. Let A be matrix and any row echelon form of A. Okay, so then the number of R, of leading entries of A I'm gonna skip and then it's called rank of A. So we denote rank of A, like that. Okay, so let me highlight rank number of R of leading entries of A. So basically, we might think a number of PV column, right? Think number of PV column. Okay, so let's see. Did we do this one before? So we have a matrix. Let's say the A. We have 1, 2, 3, and 1, 5, 9, 2, 4, 6. All right, so let's say that this one, we have reduce the row echelon form. So we have 1, 0, -1, 0, 1, 2, 0, 0, 0. What is the rank? So what do you think?
2.
Excellent. This is 2 because there's a 2 leading entry, right? So 2 leading entry. We can say that 2 PV column, right? 2 PV column. So it's a 2. Good job. So they talk about the R. R is a rank. Just using first letter of rank, right? So let's do that. R equals 2. Okay, now data 1.5.1. They talk about the rank solution to homogeneous system. Solutions to a okay, let me spell correct. Genius system. Okay. Oh, go ahead.
Oh, I'm so sorry. I was late. That was what happened.
Okay.
Yeah, thank you.
N by N. Coefficient matrix. Corresponding to a homogeneous system of equation. And suppose A has rank R, then the solutions to the corresponding system as n minus r parameter. Okay, so in the case, look, n by n, so we talk about only coefficient matrix in the case, right? So we don't count the constant matrix. So this is a row, this is a column, right? And let's say that A has a rank R. That means the PV column, they count, right? So number of PV column. Then the solution to the corresponding system has n minus r parameters. That means we are talking about number of non-PV column, right? You guys okay with this? So basically, number of non-PV column is number of free variable, right? Okay, so let us do this one. Okay, let me talk about this one. Okay, this time theorem 1.5.2 rank and solutions to a consistent system of equations. Okay, now let A be the my. Look, in that case, they add 1. Looks like they add constant term, not constant term, constant. So we had n is the column, right? So coefficient matrix, right? So coefficient matrix. And looks like 1, they add 1 is a constant matrix, right? Matrix. Oh. Okay, so we know M. All right, then augmented matrix corresponding to T. Matrix corresponding to consistent system. What is a consistent system of equations in n variables? And suppose A has R. Rank R. So consistent system means there is at least one solution, right? At least one solution. And they say that the first one, the system has a unique solution. The size will be if the rank R equal to same as the coefficient matrix size N, right? So column, same as column. So this is looks like this, right? So 1, 0, 0, maybe 1, 1, 0, 0, 2, 0, 0, 1, 3, right? So look, P big, right? So rank is the same as N, right? You can see that. And in that case, X equal to 1, Y equal to 2, Z equal to 3. At least a unique solution, right? Make sense? Number 2, the system has infinitely many solutions. If the R is less than N. Okay, so that is, maybe I can give it an example like this. So that is 1, 0, 0, 0, 1, 0. How about 4, 5, 0, 0, 0, 0. Yeah, so this is well known about infinitely many solutions because this is a true statement, 0 equal to 0, right? And this is X, Y, Z. P big, free variable, right? So R in the case 2, and in the case is 3 columns, right? So definitely we can say that R is less than 3. Yeah, it's okay. All right. Let's move on. We're gonna do just one problem from 1.6. It's about the balancing chemical reactions. 1.6, balancing chemical reactions. Okay, so I'm not good in the chemistry. I don't know anything about that. Well, I'm gonna just explain to you like a linear algebraically, right? Okay, so they mentioned that balancing chemical reactions. So to balance To balance, let me write down to balance. So they mentioned that atoms on the left. So basically like this, we have this chemical. So we have, for instance, we have S and this is called, okay, O2 plus H2 and SN plus H2O. Okay, so this is tin. They said tin, SN, and O2 is oxygen, which is just O is oxygen, right? And H is hydrogen, and tin, hydrogen, and oxygen, right? So to make a balance, atoms on the left, so on the left is here is on the left, matching the corresponding numbers of atoms on the right. Okay, because atoms neither are destroyed or created reaction. Destroyed nor created reaction. Okay, okay, then how do we make a balance? So here, let's take a look. We have tin. Let's denote tin. We give it to the look. We give it to, this is X, this is Y, this is Z, this is W. All right. So let's label X, Y, Z, W. Okay. Now, then we can label tin is here, tin is there. So X equal to Z. How about oxygen? O. So oxygen in X, right? So we are using X. But then look, we are using this 2 as a coefficient. So we have a 2x equal to, O here, there is only 1. So just W, right? So 2x equal to W. How about hydrogen? Hydrogen, they have a Y. And hydrogen has 2 as well. So we say the 2y equal to hydrogen, there's a 2w, right? Okay, now we're gonna make a homogeneous equation, means that we make one side everything and other side equal to 0, right? So there's a homogeneous equation. Spell. Spell. Okay, I'm not gonna write down. Okay, so this will be x minus z equal to 0 and 2x minus w equal to 0. And this will be 2y minus 2w equal to 0, right? Okay, let's make augmented matrix. So we get 1, 2, 0. Because does not have 0. Does not have y, so 0, 0, 2. Okay, and z -1, 0, 0, right? W 0, -1, -2. Please correct me if I make a mistake. 0, 0, 0. Okay, that is augmented matrix. Okay, now. What should I do? This is a leading entry. This is good. And then we want to make a 0 here, and then we want to make a 1 here, right? So we want to switch over row 2 and row 3. Zero, 2, 0, and 2, 0, 2, 0, 0, and 1. Okay, now we want to make a 1, right? How? 1 here.
Multiply it by a half.
Yeah. So we do 1/2 R2 make a R2. So 0, 1, 0, -1, 0, right? Okay. I want to make a 0 here. How do you make a 0? -2 R1 plus R3 to get R3, right? So that is 0, 0 to -1. Okay. Now, we want to make 0 here. How do you want to make a 0? 1/2. 1/2 R3 plus R1 to get R1, right? Okay. So this will be 1, 0, 0, -1/2. 0, 0, 1, 0, -1, 0, 0, 0, 2, -1, but I want to make 1. I want to make 1 here. How do you make 1? 1/2. R3. R3, right? So 0, 0, 1, -1/2. 0. Okay. All right. Which one is a free variable?
W.
W is a free variable. Excellent. So we have X, Y, Z, W, free, P big, right? P big, P big, P big column, right? Okay, so I'm gonna write down first row, that is X minus 1/2 W equal to 0. Second row, Y minus W equal to 0. Third row, Z minus 1/2 W equal to 0. And W is free. So say W equal to T. Okay, then we will get X equal to 1/2 W. That is X equal to 1/2 T. This is Y equal to W. That is Y equal to T. And this is Z equal to 1/2 W. That is Z equal to 1/2 T, right? Okay, now. So we can answer, this is the infinitely many solutions, right? We can pick any number. So let's say the pick, let W equal to any number. So 2, your book said 2, so I'm picking 2. So then X equal to 2, so we get 1 there, Y equal to 2, Z equal to 1 there, W equal to 2, right? All right, so let's write down. We have this one. Okay, so 1. X equal to 1, so we said 1. Y equal to 2, so Y equal to 2, we're gonna write down 2. Z, which is 1. And W, which is 2. Okay, let's take a look. We get same expression, left side and right side. So they said preserve total number of atoms, because here is 1, here's 1, right? Here is 2, here is 2. So we say that the chemical reaction is balanced. All right, let me write down. The expression contains the same number of atoms of each element. This means that it preserves the total number of atoms. So the chemical reaction is balanced. Okay. Thank you for coming for today. You have a nice evening. Thank you. Bye.